In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. Like the vanishing point in a perspective drawing, the core of a neighboring galaxy attracts our gaze and makes us feel as though we're staring down a deep well with a bright, shining center. But this illusion conceals an even deeper truth. Investigations by the Hubble Space Telescope suggest that at the center of most galaxies, there lies a giant black hole. A real-life vanishing point into which matter and light can disappear, never to be seen again. A black hole is a bizarre place where weird physics reigns supreme. But the force that gives rise to a black hole is the same force that governs just about everything we see in the universe, from planets to stars to entire galaxies. It's gravity. Located on the outskirts of our own galaxy, the Milky Way, this is a globular star cluster. Although it's much smaller than a galaxy, it's still mind-bogglingly huge, containing hundreds of thousands of individual stars. Held together by their mutual gravity, these stars have arranged themselves into a perfectly spherical cloud. On a smaller scale, gravity is the force that brings atoms together to make stars and planets. These objects look round because a sphere is the smallest volume into which a given amount of matter can be packed. And the more matter available, the stronger the force of gravity that pulls it all together. Among the nearest stars to Earth is Sirius, the brightest star in the night sky. It's sometimes called the Dog Star because it belongs to the constellation Canis Major, the faithful canine companion to Orion the Hunter. Looking at Sirius up close, the Hubble shows us that the Dog Star has a companion of its own. Known as Sirius B, this tiny star is an example of what gravity can do under more extreme circumstances. Astonishingly, Sirius B contains as much mass as our Sun, yet it is no larger than Earth. This has happened because Sirius B is a dead star. When its energy ran out, gravity took over and compressed its atoms into an ultra-dense state known as a white dwarf. Elsewhere in the universe, gravity makes possible even more extreme states of matter. For example, the violent supernova explosions that mark the deaths of the brightest stars also unleash enough energy to create neutron stars. In a neutron star, atoms are crushed together to form an object 10 trillion times as dense as solid lead. A typical neutron star contains nearly twice the mass of our sun, yet it is no larger than a small city. Because they are so small, neutron stars are very faint. Yet with its eagle eye, Hubble can spot a lone neutron star adrift in interstellar space. Since a supernova can produce a neutron star, it makes sense to search for one where a supernova has occurred in the recent past. In 1987, a supernova lit up the skies of the southern hemisphere. When Hubble was launched a few years later, astronomers were eager to observe the aftermath. What they found, nestled in this rose-colored cloud of interstellar gas, was a strange and remarkable sight. At the very center of this image is the exploding fireball of the supernova. But it's encircled by a bright ring of material that was released before the star exploded. Over a 10-year period, Hubble has watched this ring brighten as it's heated by the expanding shock wave from the supernova. In a universe where change is typically measured over millions of years, Hubble has given astronomers a rare gift: front-row seats to a stellar explosion in progress. And like a cosmic Christmas wreath, the ring is now aglow with supernova energy.
It's here in the center that astronomers have been looking for the neutron star, but so far it hasn't appeared. Perhaps the neutron star is still concealed in enveloping layers of dust. Or perhaps the size and gravity of the star that went supernova was enough to create something else: a black hole.
When matter can no longer resist the relentless pull of gravity, it forms a black hole. A region of space where the gravitational field is so strong, not even light can escape. To encounter such an object adrift in space would be to see nothing at all, except the light of background stars bent by gravity around the edges of the black hole's event horizon. Even more intriguing is evidence that at the center of our galaxy there lurks a black hole of gigantic proportions. The giant black hole is not visible to the Hubble because it lies concealed behind the dark dust that screens the central region of the Milky Way from our direct line of sight. So to hunt for giant black holes, Hubble must turn to other nearby galaxies where it can peer directly into their central regions. This is the Andromeda Galaxy, a vast, swirling metropolis of stars that is twice the size of the Milky Way. A decade ago, astronomers were puzzled by a strange bluish light that seemed to come from the very center of Andromeda. With Hubble's help, they have now solved the mystery of the blue light. It is produced by hundreds of bright blue stars, wheeling around Andromeda's center at speeds approaching 20 million miles or 32 million kilometers per hour. only the powerful attraction of a giant black hole could force stars to race so quickly. Even further away than Andromeda, in the galaxy Centaurus A, Hubble finds more direct evidence for the existence of giant black holes. This galaxy is surrounded by a ring of dark dust, dust that was acquired from a smaller galaxy that merged with Centaurus A long ago. A classic case of galactic cannibalism. Looking deeper into the partly obscured heart of Centaurus A, Hubble unveils what astronomers once could only imagine: a glowing core where gas from the cannibalized galaxy is feeding a giant black hole. Unlike the black hole at the center of our Milky Way, this object is active and obvious. And when Hubble switches to an infrared view, it directly sights the vast disk of material swirling around the black hole. As Hubble turns its roving eye elsewhere, increasingly it finds that giant black holes are a common feature at the centers of many large galaxies, including galaxies like our own. And though these black holes ultimately destroy what they devour, Hubble's exploration of them has left us with a surprising revelation.
These mysterious and terrifying monsters, the universe's vanishing points, may have played a critical role in the formation of the galaxies that surround them. If so, they are key components of Hubble's universe, a universe that not only offers great beauty, but that also populates itself with curious creatures who can ponder the remarkable circumstances of their own existence.
Spreading before us like a giant canvas, the universe revealed by the artful eye of the Hubble Space Telescope is a universe of opposites. At one extreme, the stars burn white hot, sometimes illuminating colorful clouds of interstellar gas with their high-temperature glow. At the other extreme, the darkness between the stars is a frigid vacuum, a space so empty we would need to scour 1 million cubic miles, or 4 million cubic kilometers, to find enough atoms to make a single drop of water. At first glance, these extremes of light and dark do not seem to offer much hope for life in the universe. The stars are too hot, and space is too cold for life to exist. But fortunately for us, there is more to this picture than meets the eye. Planets that orbit around the stars offer the promise of a middle ground between the universe's two extremes, a habitable zone where life can gain a foothold. Our own solar system is the starting point in our understanding of how and where life can emerge in the universe. Here we find a diverse family of planets, ranging from small and rocky to large and gaseous. We also find that on at least one of those planets, Earth, conditions are just right for life to flourish in abundance. The small fraction of the sun's energy that splashes onto our world is just the right amount for water to exist as a liquid. And that same energy sustains millions of species of plants, animals, and microbes. Elsewhere across the galaxy, we find the building blocks for planets and for life scattered among the stars. It's natural to wonder how much life could there be in the universe, and where should we look for the planets that can support it? These are not just fundamental questions of science, but questions that lie at the heart of our own sense of what it means to be alive in a vast and mysterious universe. Only recently have astronomers had the tools to begin the search for life in the universe. And among the most powerful tools of all is the Hubble Space Telescope. Like other telescopes, Hubble faces a serious challenge. To search for life, astronomers must search for planets around other stars. But even for Hubble, those planets are too faint to see directly. Instead, Hubble has found clues that reveal how and where planets form in our Milky Way galaxy. The birthplaces of new planets are the same places where we can see stars in the making. They are towering clouds of dust and gas, where material is gradually pulled together by the force of gravity. Cloaked behind a veil of dust, hydrogen and other atoms begin gathering inside the clouds. As they grow more concentrated, they pull in more material until the entire cloud coalesces into a cluster of infant stars. Powered by nuclear energy, young stars can shine with a light so intense it pushes aside the cocoons where they were born. And as the dusty veils are lifted, Hubble gives us a front row seat to the creation of new worlds. The Orion Nebula is the nearest star-forming region in our galaxy, and so it gives us the best chance of seeing how new stars give rise to new planets. In its central region, a quartet of stars shines with the light of 10,000 suns. Together, these bright stars have formed a hollow cavity within the Orion Nebula, allowing astronomers to peer inside. What they have found is a large population of freshly minted stars, and also something more. Many of the stars at the center of the nebula are surrounded by leftover material from star formation. This includes dust, which is easily spotted because it absorbs light and appears dark against the background glow of energized gas. In example after example, we find that rotation and gravity have acted together to shape the dusty material into flat disks that swirl around their stars. Over a period of tens of millions of years, the material within these disks will eventually start clumping together to form planets. Astronomers have long suspected that solar systems form this way, but only with Hubble have they been able to capture the process in action. To gain further insight into the story of planet formation, astronomers have focused their attention closer to home, using Hubble's resolving power to search for disks around nearby stars. In this image, the light of a star similar to our own sun was artificially blocked by Hubble's camera. This allows the space telescope to discern a faint reddish glow around the star, a glow that is caused by a surrounding disk of dust. The dust particles that are responsible for the glow are tiny, like particles of smoke. But buried within the disk, astronomers suspect there are larger clumps, the building blocks from which planets can form. Here, Hubble discovers what at first glance appears to be a giant eye in space. This is Fomalhaut, a bright star located in the same part of the Milky Way galaxy as our own solar system. Once again, the star's light is artificially blocked to reveal the faint light of surrounding dust. But here the dust appears as a narrow ring. The ring is a strong clue that a planet has formed around Fomalhaut. As this illustration shows, the planet likely orbits just inside the ring, where it's in the process of sweeping up dusty material. Meanwhile, Beta Pictoris, another nearby star, offers a different angle on planet formation. Here, a dusty disk is seen almost exactly edge-on. This is Hubble's sharpest view of Beta Pictoris, and it reveals a surprise. The star is surrounded by two disks rather than one. A likely explanation for this is that the gravity of a newly formed planet is disturbing some of the dust that orbits the star, creating a slanted second disk. Hubble's observations of disks around other stars have allowed astronomers to see what planet formation looks like from a distance. It's also been like a time machine that lets us see what the origins of our own solar system may have looked like 4.5 billion years ago. In a different way, Hubble is also helping to find planets that formed in the past. To do this, it has stared into the densest part of our Milky Way galaxy, toward a dust-free region known as the Sagittarius window. The result is this dazzling view that contains some 200,000 stars. The odds are that in a sample this large, many stars will have planets. And a few of those planets may pass in front of the stars they orbit just when Hubble is watching. Sure enough, when Hubble monitored this portion of the sky for 7 consecutive days, it spotted several stars temporarily growing dimmer by a small amount. In one case, a star dimmed every 10 hours with clock-like precision. Follow-up observations have confirmed this star is circled by a planet with roughly the same size and characteristics as Jupiter. Such a planet is not the kind of world where life as we know it would find a comfortable home. Nevertheless, this groundbreaking work by Hubble is blazing a trail for future space telescopes, which will someday be sensitive enough to detect Earth-like planets as they pass in front of their stars. By opening the door to the discovery of new worlds, Hubble is bringing us closer to answering one of the most important questions of human existence. Are we alone? Our presence means that we are not just passive spectators of the universe. As Hubble has now revealed, our planet, like so many others, has sprung from the raw materials of the universe, and it's led to our emergence as an exploring species. This realization gives new meaning to the striking vistas we see spreading before us as Hubble probes the deepest corners of the cosmos.
What makes the universe so beautiful is not simply the matter and light that gives rise to such extraordinary variety and detail. It is the fact that we are here to see it, the living witnesses that makes this a living universe, a conscious universe, a universe that can see through the eyes and minds of those that live within it.